This is a video on how to factor out the GCF from a polynomial. So we have here 4 examples. I'm going to space them out so you can realize how close they work together. All right, so first thing, if you don't know how to find the GCF, please watch the prior video because that would be step 1. So identify or find the GCF first. So here we have 3 items. Now I always look at the most basic item here, and that's 12. Now you should have some experience finding the GCF, so this should not be like your first go around with that. Now I'm looking at the 12. It does not contain any x's, so I know my GCF will not have an x term in it. It will only be a factor of 12. Okay, so if I look at 12, I have 1 times 12, I have 2 times 6, or I have 3 times 4. Now, really, I have 2 other numbers to check here, and I can see that 4 goes into 4, but 4 does not go into 18. I can see that 6 goes into 18, but 6 does not go into 4. So I know those are not my greatest common factors. How about 3? Does 3 go into 4? No, it does not. So I can stop there. 2, however, goes into both of those. It also goes into the 12. So the GCF in this problem is simply just the number 2. Again, if you need more help with that, watch the prior video. This video is not going to help you. So what I'm going to do here is essentially, I'm going to rewrite this whole parenthesis again, okay? Because I'm going to take that 2 out of each of those terms. Essentially, now I'm putting that 2 in front. So it's really now 2 times whatever's left. Now how do I get whatever's left? I'm going to basically just divide each piece by the GCF. And if I divide 4x squared by 2, I get 2x squared. If I divide this negative 18x by 2, I get negative 9x. And if I divide this positive 12 by 2, I get positive 6. And this would be my final answer. Okay, that is factored to our current level of ability. Now, it could be, eventually, once you learn how, it could be that the resulting polynomial inside the parentheses might be factored further. But usually, you're typically going to be benefit from finding a GCF first because it makes the inside a smaller version of that polynomial. Okay, again, we're going to find, I'm going to change this number a little bit. We're going to find, you know what? No, I don't have to. Just kidding. We're going to find the GCF here. I'm looking for factors that go into both of these. And you can start to see that there's actually an easier way to just think about the GCF and say, okay, what would I be able to divide both of these numbers by? And it's clearly 6, right? GCF is going to be 6 here. I'm going to factor that 6 out, and I'm going to divide each piece by 6, and you should get x minus 2. Okay, that was kind of an easier one. That's like a very simple GCF problem. Now we're talking a little more complicated. The numbers here are 72 and 66. If you know your factors of 72, you can clearly see that 6 is going to be a factor of both of these. And then if I'm looking at the variables, just start with the x's here. There are 4 x's here, there are 2 x's there. So I'm going to take whichever are fewer, and that's going to become part of my GCF, part of it. So there's 4 here, there's 2 here. Both of these will be part of my GCF. And then similarly for the y, I have 1 y here, I have 2 y's here. Okay, so this 1 y is going to be part of the GCF. So I have 3 chunks here. I have 6, we have x squared, and we have y. These 3 pieces end up being my GCF. So 6x squared y. If I divide this by 6, I get 12. If I take 2 of these x's away, I'm left with 2 x's. If I take this one y away from this y, it is now gone. It's outside. I didn't factor out a negative, so this positive is going to stay positive. 6 goes into 66 11 times. Both of the x's are gone, so that's not even going to show up anymore. And I've taken one of those 2 x's out. So if I took one out, I have 1 left. And there's my answer. Okay, one last one. Pause the video, give that one a shot. Again, I think this one's fairly easy. This last value has no variables. That means my GCF will also have no variables. What goes into all 3 of these numbers? How about 9? Okay, take the 9, put it outside, out front, multiply in the whole parenthesis, and divide each term by 9. Nope, that's not quite right. And you really have 1x there. I don't show the 1. And then 18 over 9 is the 2. And that's factoring out a monomial.